Okay, ladies and gentlemen, so welcome to today's event. I can't actually recall the first time I met Usama, but it was certainly at least 20 years ago. He hasn't changed a bit. But, those of you who are as long in the tooth as I am will recall his edited volume, Advances in Knowledge Discovery and Data Mining, published in 1996, which was the first real book on data mining. It was one of the seminal influences on the discipline. He took a PhD in engineering from the University of Michigan in 1991. He's a fellow of both the Association for the Advancement of Artificial Intelligence and the Association of Computing Machinery, and I think he's the only person who's received both the ACM Special Interest Group Knowledge Discovery and Data Mining Innovation Award and Service Award. He launched and served as editor-in-chief of Data Mining and Knowledge Discovery, the leading journal in the area. He's had a varied, dynamic, and highly successful career of leading the data strategy of major companies and also of launching his own startups. I'm afraid we don't have time for me to list all of the posts he's held, but here are just a few of the highlights. He worked at Microsoft for 5 years. He launched Audience Science, his first startup, in 2000. In 2003, he co-founded the DMX Group, a data mining and strategy consulting and technology company that specialized in big data analytics. DMX was acquired by Yahoo later. From 2004 to 2008, he served as Chief Data Officer for Yahoo. And to give some context in terms of the modern term big data, this processed over 25 terabytes of data per day. In 2008, he founded Open Insights, a data strategy, technology, and consulting firm. Most recently, he's joined Barclays as their chief data officer. The mere fact that an organization such as Barclays has someone with that title tells you a lot about the way the banking industry, and indeed the world in general, is going. If I can inject a personal note here, I've myself have undertaken a lot of consultancy work with Barclays over the years, including working with Barclaycard, Barclays Direct Loan Division, and Barclays Capital. Most recently, I had discussions with them about extracting value from some of their very large customer behavior databases. Given this, it's very clear to me that Usama has some wonderful data to play with. I think if anyone and anything can demonstrate the power and benefits which can come from effective analysis of massive data sets, then it's the combination of Barclays and Usama. And I look forward to reading some of the advances that he's led in the near future. It's a genuine pleasure this evening to invite Usama to give us his distinguished guest lecture. Usama.
Thanks very much. Thank you, David, for a most amazing introduction. I'm glad this is on video. Although I will correct David on two things. He claimed I didn't change in 20 years. I'm 100 pounds bigger in weight, probably an all-time high for me. Nothing I'm proud of. But David did omit one of my passions and one area I'm very, very proud of. I started out my career at NASA, JPL, working on the analysis of what was then called massive data sets. Today, I guess we would refer to them as big data and lots of unstructured and image data and so forth. And I learned a lot from NASA and the transition to sort of the business world, Microsoft and Yahoo and other places. If we have time, we won't today because I have a lot of slides, and I want to also leave time for discussion. So one of your jobs here is to hit me with hard questions at the end. And my challenge is to keep enough time to cover those questions. Let's get started. So I want to talk about big data all around us, sort of define it. Why is it there? Why should we care? I'm going to make an argument that almost all data is big data. And in fact, interestingly, big data term has become so popular, people are looking for new terms. And one of the new terms is all data, that you'll probably start hearing about over time. A little bit about this chief data officer role. You know, when I joined Yahoo, we created the title. We made it up. And it was half joking. Like, I didn't want to have a title, and, they came up with a bunch of titles I didn't like. So, one of the guys said, Chief Data Officer, and Jerry Yang, who's the co-founder, said, I like it. And I said, Chief Data Officer sounds like it's fun enough. So it's really funny now how the world took it so seriously, and almost every bank has a Chief Data Officer, and good to see that stuff. But it is a real role with real needs and so forth, and I'll talk a little bit about that. Then I'll do some case studies to introduce, what's happening with predictive analytics over big data in particular, and end with a couple of summaries. Right, so what matters, and the short story here, what matters is not how much data you have and how much infrastructure you have, is that data reaching the people that it should reach, i.e. the decision makers, the people who can act on that data? Can they understand it? And can you make the use of data prolific? If you ask me today, in most companies, in most organizations, do people really utilize data? The answer is sadly no. And one of my dreams is to get to a world where we create an organization where everybody is tuned in. Somehow, as part of your daily life, you see stuff that matters, that comes out of this data. And a lot of it will be unstructured data. And is it driving value? So big data, the term. It's a new term with an associated data scientist position. And for the students here, you should care a lot about data scientist because it's one of the highest paid positions ever. So as you write your CV, make sure to call yourself a data scientist if you can, because that will get you a premium. Big data is a mixture of structured, semi-structured, and unstructured data. So semi-structured would be something like a document where we have some structure over it. We know what the headings are, what the sections are, what certain things mean. But generally speaking, it's a lot of text. And then unstructured would be things like images, where there's a lot of data. We don't really quite understand as a computer or a database what's in it. And typically when you use it, you do a lot of pre-processing and try to figure out, how do I extract what I need? How do I get structure out of it so I can analyze it, And the above leads to very messy situations with no standard recipes of what to do. So that's why I think the data scientist term is very apt, because what you do with these data sets is mostly what I call data expeditions. So you go exploring. You probably end up discovering stuff you didn't expect. You never achieve the goal you went after, but you get something else that's equally valuable or more valuable. And therefore, I think sort of the whole data scientist analogy does work. So today, we'll talk about the 4 V's of big data. And in the industry, people talk about the 3 V's. Volume, which, by the way, is the easiest one to deal with. And there you can quote all sorts of numbers, and they seem amazing, and lots of volume, all of that kind of stuff. And volume, as David can confirm and tell you, it's not. That's the easiest one to deal with. Velocity, the rate at which this data arrives. So can you process it in time? Can you respond in time? Can you figure out how to extract what you need out of it and make a decision in time? That's a challenge. In many cases, you can't even afford to go back. And David mentioned that Yahoo used to process 25 terabytes of data per day. By the way, if we messed up, there's no time to ever go back. It takes actually about 24 hours to process that data, or it took us then. And that's it. Once you fall behind or you fail to process a part of it, you can't just reprocess. So you have to figure out how to live in a world like that. Variety is the worst, right? In classical statistics, that's the curse of dimensionality. It shows up in many, many, many ways. In the database world, it shows up, the symptoms are, you get a lot of blobs and clobs in your database. Do people know what blobs mean? So blob stands for binarily large object, i.e., I take an image and I store it in the database as a binary object. It's just fancy code to say this database understands nothing about this data, so the query processor, the query optimizer, any of this stuff can't do anything with it, right? Clobs, what's clobs? See, these are sort of dweeby technical database terms. Character large object, another word for document, right? So they take a whole document, a bunch of text, plop it in as a field, right? And say, we can handle now text data, right? Again, you don't understand what's in it, and it's not very useful, but it's stored. So let's talk a little bit more. I'm going to share with you something that looks more like classic data. This is highly structured data, even though it's a lot. So this is, at Yahoo, we call this our user DNA. So what is that? This is, think of it as a long strand. If for every user, and at my time, Yahoo had about 600 million of them when I left. I think today they have about 700 million. For every user, we would know things like what is their gender, where do they live, maybe what they do for work, right? Some behaviors they exhibited, clicked on something, searched on something, etc. And we had about 2,500 to 3,000 of these properties for every user. Now you look at this and you say, this is big, but this is very structured, right? And one of the changes I made, it used to be 0, 1, did you click, did you not? And I changed that to a score, sort of that indicating the likelihood that you might click on something, etc. But that's still structured data. That's easy. So let's take another view of the same data. You guys have heard of something called LinkedIn, right? So, okay, you're a lawyer, you live in SF. I can go into LinkedIn and look up all sorts of stuff about your practice, about your colleagues, etc. I can go off and do Google searches on you, right? And get all sorts of stuff about hobbies, activities, etc. And if this is scaring you, it should scare you. I'll go to something called Facebook, if you've heard of it. And I'll get all sorts of information about your interests, your so-called likes and dislikes and what have you. This actually is interesting. About 2 years ago, 2 or 3 years ago, I had 2 interns from France who came to spend time with one of the startups I was doing on the side. And I gave them an assignment. It was a company that does sort of real-time offers for mobile. So one of the things we cared about is trying to guess your commercial interests. And I gave them a challenge. I said, if you went on Facebook, right, if you had access to my Facebook graph, can you guess what my commercial interest would be, right? And this was a real challenge because I used Facebook a long time ago, right when it started, because I was at Yahoo and we were doing competitive intelligence. So, somehow I wound up with several thousand friends. I don't know how, people just keep friending me. And maybe I did a few likes in my past, like maybe 3 or 4 likes, right? So I figured these guys are not going to find anything about me. They came back with an amazingly accurate profile of what I would be interested in commercially. Now, how did they get that? Yeah, the friends likes, even though these are, quote-unquote friends, I don't know most of them, but somehow they are close enough in their circles that their likes say a hell of a lot about my likes commercially. Like, I'd be interested in these kinds of cars and these kinds of clubs and these kinds of, offers. So it's pretty scary stuff. We keep going, because this is all public data, by the way. You go on YouTube, Flickr. Does anybody know what Flickr is? Right? A site where you share photos, right? And pretty amazing story there. I was part of the acquisition of Flickr, and it was a really interesting story. But a lot of rich data that you can find about people and what they like there. And of course, there's the traditional tags and meta tags and so forth. And there's blogs, publications, news, all sorts of stuff that you have access to. Now, here's what I'm saying. Why am I showing you all this? A lot of this data here is unstructured or semi-structured. There's a lot of graph data, which most people don't know what to do with. And almost any database you can think of. A list of students at IC, right, can be enriched in this manner. Right? So suddenly, you take a traditional database that you think of as traditional, highly structured, and you can annotate it in no time, literally in no time in today's age, with all sorts of these structures, and suddenly you've got a big data set on your hand, and most of the world doesn't know what to do with these big data sets. Thank God so far, but we're getting better. So the distinction between the two is fast disappearing, right? And that's because we can do a lot of these overlays that I talked about. The dirty little secret, though, is most of the work on big data, on unstructured data, is about text data, right? So people talk a lot. So Google has image searches. You're familiar, you can search for images on Google. Does Google understand what's in the image? What do you think? The answer is absolutely no. They have some applications that do. What they look for is actually the text around the images and the anchor text that points to an image. And that gives them big hints as to what's in that image, right? So literally, they don't understand what they're returning to you other than this happens to have this text around it and all that. And we're going to come back to that. So that tells you how powerful at least just the text indicators are. And on the internet, there was a huge pressure on the companies that do indexing. If you're a Google or a Yahoo or a Microsoft, you have a problem. You have to keep a full copy of the web, total copy of the web. And you have to re-index it multiple times a day, sometimes every minute, right? Like news sites like CNN and so forth have to get re-indexed often. And a web page like mine, probably once every 2 years is enough. But that's a real problem. You have to count. And most of it is about counting words, finding keywords, filtering them, stemming them, et cetera, and then coming back and saying every document is just a bunch of keyword counts, and here's they are, and this is what we use in matching in search. If you want to do that, you better be able to do it in parallel over plenty of cheap hardware. And that's what MapReduce is, and this is what we'll talk about soon, which is Hadoop, right? So this is a technology where we took that indexing infrastructure, the ability to take an operation, map it to a large number of processors, execute it in parallel, and bring it back together in this MapReduce framework. And we'll come back to that in a second. So big data applications, they're everywhere in many different areas. I chose to put IT, log, and security up on top. Do you happen to know what is the hottest public company in big data today? Let's see if anybody knows. Care to take a guess? Have you heard of a company called Splunk? Okay, public company, very hot. You know how they started their business? By actually saying, we'll take IT logs, right? Literally, like the IT systems and the error messages and all the logs they generate, and we'll help IT people visualize these. And they actually built a big business on top of it. Went public. Of course, now they're moving into many other areas of big data. So a lot of this stuff is happening, and it's generating a lot of value, and it's happening in strange places. I wouldn't have expected the biggest company to come out of IT logs, for example. I would have thought advertising analytics, and I can talk about that for hours. But a few words on the chief data officer. I think I'm going to skip this mostly, but it's basically, to me, I say it's the voice of data at the executive table. How do you help a business team figure out what the data means? How could it create new businesses for you? How could it drive revenue? What are the dangers in it? And if you do it right, how can you essentially create competitive advantage and big growth, right? And that's what we're trying to do with our data now at Barclays. But the reason I talked about the CDO for one slide is because I wanted to spend a little bit of time on this. I'm going to give you my I'll call them Usama's obvious data axioms, because you're going to look at them and you're going to say, this is damn obvious, right? Data gains value exponentially when integrated and coalesced. Loses value when it's fragmented, right? It's a strange thing about data, right? The more you centralize it, the more value you can get out of it, which is not, you don't get that in a lot of places. Obvious to you? Yes, if I know data about you, how you perform in school, and I had other data that talks about, your hobbies, well, if they were fragmented or together, where would you get more value? As an example, if I'm trying to market to you, for example, right, et cetera. Examples of that. Fusing data together, since putting it together makes it more valuable, is way more difficult to do after the fact, much easier to do at source. Sounds familiar? Sounds easy? Sounds reasonable? So where I'm heading with this is, by the way, in almost all large companies, even in small ones, data is a mess. And even if it's a new company, just wait for a couple of months and you will have a mess on your hands. And typically that mess comes from the fact that people don't think about this. How do I bring this data together? How does it fit together? Oh, let's fix it now a year or two later. Good luck, right? And in fact, this is where people waste amazing amounts of money trying to do this post hoc. Axiom 3, standardization is essential. Right? This is, if we didn't have standards to say, well, we represent, industry codes this way, right? This is how we, represent different, say, names of courses or whatever. if you don't have standards, you quickly have a Babylon on your hands. And we all know what historically happened to Babylon because they couldn't have a standard. Data governance and policy must be centralized. This is all about, if you have a standard, how do you make sure you stick to the standard? Recency matters. Sounds really obvious. What does that mean? That means if I'm, for example, watching how my customers are using, say, my bank, and I want to service them quickly, right? Let's say, I'm going to quote you an example where Barclays is doing the good thing. You all know that if you overdraw your account, the bank is going to slap you with a fee, right? And that's a good income source, by the way, for the bank. So as long as you can replenish your account, banks are typically very happy to have you go over the limit frequently and as often as you could. So what did we do at Barclays? We actually said, look, this experience is not right. What if we gave you a window? What if we gave you an alert within minutes of you going overdraft and gave you a few hours to go fix it? If you fix it within that time frame, we won't hit you with a fee, right? Sounds a bit more fair, more acceptable. Some of the revenue guys complained, but that takes away my revenue. You know, CEO said, no, this is the right thing to do. To do this in a bank is not easy, right? This means that I ought to be able to detect it, and the minute I detect it, I actually have ties to an SMS system that alerts you in time and that verifies that you got the message. We do this all the time in fraud detection and other things like that. That is also very, very important. So if I give you this information 3 days later or at the end of the month, which is how it's typically done, it's not so useful. If I give it to you now, it's very, very useful. But I got to do it at scale. I'm going to skip these because they're a bit too technical, but I think they're still obvious. And data is a primary competency. What happens in most companies is they don't think hard about data. So it gets done as a side effect. So people who don't specialize in it can easily build a mess for you. Now, I shared these with you to tell you this is why you need something like a chief data officer, because these obvious axioms, if they are obvious to you, I hope they are obvious to you. They are not obvious to 99.9% of the companies out there. And that's why most companies and organizations and governments don't get it right, right? So these simple, obvious axioms are actually very, very powerful if you get them right. All right, so now let's go back to the main topic of this talk. Let's do a reality check. Let's say you're a company and you want to see, what are people saying about me in all this social media, say on Twitter, right? You get answers like this. Here's a nice graph. Actually, I borrowed this graph from another talk, but you can actually, in live, go in and sort of visualize the graph and fly around it. And this is a graph on Twitter showing how some tweet spreads. Is this useful to a business person? It's fascinating, but what do you do with it, right? So your next question is, well, surely there must be some companies that can help me understand this stuff, right? So who do I go to? And this is a chart, and I made it small on purpose. But it lists a whole bunch of companies who actually say, our job is to help you understand what's being said about you in the social networks. And it's a mess. I actually don't know most of the companies on this chart. And this chart is 2 years old. So today, it'd probably be 4 times the size. So my point is, it's very, very confusing. Who do you go to? Who really knows what they're doing? And can they service what you want? So again, they're lost in that mess. So what do the technology people, us in the university here, what do we worry about? What's the debate? The debate is to Hadoop or not to Hadoop. This is what data is, big data is, for most academic institutions and sort of research labs. So what is Hadoop? Hadoop is basically an open source project that actually started mostly at Yahoo, of saying this whole technology for doing MapReduce, this ability to take a bunch of computation and apply it in parallel and gather the results and manage a lot of commodity hardware. We got to make it easy. And so Hadoop got released, and then companies came up to support it. So you have companies like Cloudera, Hortonworks, MapR. Cloudera, I think, is about to go public, another big data company. But that's the debate. Do I use Hadoop or do I not use Hadoop? And is it efficient or is it not efficient? In reality, what's driving this Hadoop in most organizations is cost of storage. So this is amazing to me. Here's a software that was written for purposes of high-performance parallel computation. The biggest driver in all places, including the bank, is cost of storage. Why? Depending on who you talk to, cost of something like Teradata, which is a high-performance database, very, very fine product, is about 100,000 per terabyte per year. If you do that on Hadoop, if you do it on your disk that you buy in the market, it'll probably cost you something like $200, $300. If you do it on Hadoop with redundancy and all of that kind of stuff, it's about 2.5K, but you get this parallelism and all of that. So look at this. I can store the data in a high-performance store at mass scale, and I can do it at, I don't know, 40 times cheaper. Is that compelling? Yes, very compelling. Wow, give me more of this stuff, right? Because I can make it cheaper. We'll talk about another reason why this stuff is becoming popular. But let's look at Hadoop for a second. I'm going to skip how it's used. But I'm going to start sharing a couple of charts with you here. Again, the purpose is not to necessarily educate, but more to confuse. So on the left are sort of the, what you'd use for analysis, SQL, MySQL, Python. Some of you may use R, etc. On the right is sort of the Hadoop world, which, by the way, I didn't update the acronyms now. There's like at least 10 times the number of acronyms, right? Storm and, anyway, there's Hadoop, there's Pig, which is a way of describing processes on top of Hadoop, like a scripting language, and then there's Pig Latin. Anyway, Hive is a way to do SQL on top of Hadoop. Hippie, Mahout, a very good package for sort of data mining techniques on top of Hadoop. And by the way, if this bothers you that you don't know half these terms, don't be too disturbed. It bothers a lot of people, right? And it gets worse, right? So here's the chart. If you know anything about databases, on the left is the non-relational world, and on the right is the relational world. Relational world means your traditional database, like Oracle and all that kind of stuff. And you've got things like, on the left, you've got things like NoSQL, which stands for NoSQL or not only SQL, depending. All sorts of other technologies. And this is where it gets scary. This stuff is evolving really fast. People are releasing products. Every month there's 3 or 4 more to add to this chart. And they all do something different. And the answer is people are totally confused and lost, right? They don't know how to use what, when, and what does it mean, and when does it work, when doesn't it work. So it's pretty scary stuff. And my message is, something will happen that will change it, which is a huge opportunity here. And we'll head to that later in the talk. So reality. If storage is the biggest driver, I'm going to ask you a question. What's the next biggest driver for using Hadoop, this thing that was created for high-performance parallel computation for? Any guesses? Yeah? Security, good guess, but no. Speed, no. Yeah. Amazing, right? All the intuitive stuff. It's this boring thing called ETL. What is ETL? Extract, transform, and load. What does that mean? That means tools. So there's public companies, again, Informatica, Ab Initio, IBM, who actually sell you tools that say, OK, here's how you connect to a database. Here's how you grab data from the database. And here's how you transform it. Sounds simple, doesn't it? But say at a place like Barclays, every time I want to access a new database, it will cost me at least £500,000 before I can even touch it. Because I got to buy these ETL tools to do it. It turns out people are now, and we're participating in an open source project to actually release Hadoop to be used for these kinds of, which is open source software, to be used for these kinds of applications, which again is another unexpected sort of transformation. Why? Because when you do these transforms, when you grab data, you're probably grabbing it from documents, Excel files, et cetera, and you want to do manipulation quickly, you want to do it at scale, and you want to do it flexibly. And this is what these Hadoop and NoSQL systems allow you to do. OK, so we talked about turning the 3 V's into the 3 V's. The 4th V, the most important, is value. And this is where I'm going to spend the rest of the talk. So understanding context and content. What are the appropriate actions? Is it OK to associate my brand, say, with this content? Is the content sad, happy? Is it a party? Is it a funeral, right? Understanding community sentiment, right? What are they saying? What's the emotion? Are they just joking, or are they, is this really bad? Understand customer intent. What's the customer trying to do? Are they, when I go on, this is one of the problems I worked on when I was at Yahoo and started Yahoo Research. Let's say I type in the search engine, this little box where you type on average 2.4 words. If I type cappuccino machine, I could be looking to buy one, right? So what search results do you want to give me in that case? Probably places that sell it, and maybe a good deal while you're at it, right? But let's say I just bought a cappuccino machine, and I'm searching again. What am I likely to be looking for? Right, how to use it. Right, 6 months later, I'm searching again. What am I likely to be searching for it for? How to fix it. Right, the search results are completely different depending on content. It's totally dependent on your user intent, yet all we see about that user is the 2.4 keywords. So understanding it is a huge deal. In advertising, it's really big. In marketing, it's really big. So, and there's applications everywhere. I'm going to skip these because I want to focus on some of the case studies. Understanding context. So now a question to you. Who is the company, like web pages, pages on the web? Who is the company that we think of as the best in the world at understanding what's in those pages? Come on, you should be able to answer. Google, good guess. 6 years ago, your guess would have bothered me a lot. I would have said Yahoo, but no. All right. So Google makes its money from ads. So I need to understand the context for ads, right? Here's an article. Body parts delivered to Michigan home. What ad would you serve with this article? Care to guess? Here's what Google would serve. By the way, Google keeps changing this, but I'm not going to update my slide. Now, is this a reasonable ad to serve, right? UPS or FedEx? Yes, because it says home, parts, delivered, right? So these are good keywords. What do you mean? They're perfectly legitimate, right? So the question is, right, is this damaging to my brand? Do I really want it to show up here in this context, right? Now, again, remember, this is, and I admittedly will admit it, the best company in the world at handling content. And they make from this business, they make about 25 billion a year, right? The rest of it comes from the other search targeting. So violence continues in Greece as rioters firebomb buildings. What ad do we serve here? Yeah, very good. You're getting as good as Google. All right. So, right? And again, this is, by the way, this is not to make fun of Google, because this is a hard problem. There are hundreds of billions of pages on the web, right? Getting this problem right every time is really, really hard. So I'm not saying they're bad. I'm just saying you guys have so many chances to create the next hot startup, right? Because these problems are worth billions of dollars a year, and they're unsolved. So here's a company I work with, Netseer, small company, small startup. They try to understand content more. And one of the examples I like to use, actually, so for example, in a good article about caffeine, they will actually serve an ad about caffeine, where it makes sense, right? But how do they get there? Here's your a page. Talks about nail gun, right? Nail gun, not the tool. We have the Google ad there for the nail guns. But it's a Java programming technology, right? If you look at the Netseer hierarchy that goes with this is what an advertiser would get. Programming in Java, Java development kit, Sun Java, Java programmers, etc. So if you were following that script on the right, you would never think about serving sort of a nail gun or a power tool ad in this page, right? And that's my point. This is a very small company with probably 1/1,000,000th of what Google got in funding. But by focusing, these happen to be graduates of UCLA who started the company. All right, another one is I wanted to talk a little bit about Yahoo, sort of our experience there to highlight some of these analytics and some of the difficulties. So we talked about the 25 terabytes data a day. I don't like the volume metric usually. So one of the charts I asked the team to do once is just give me the number of events, right? What are the events that matter? So if I compare it to the New York Stock Exchange, how many million events per day compared to what do we get at Yahoo? And that gives you an idea of how it's sort of on its own an outlier in its own right. So there is an issue there with dealing with the data. So I'm going to talk about a particular area where we generated a lot of money for Yahoo from something called behavioral targeting. So what is that? You might consume a page on Yahoo. You might go read your email. You might also search. You might look for an automobile on Yahoo Autos, etc. Maybe search for a mortgage on Yahoo Finance. All of these things give you hints to the commercial interest. And for Yahoo, they have a problem. Most people, for example, go to Yahoo to read email. Well, what kind of ad do I serve to you when you're reading email or when you're reading news? Very hard to figure out what ad, unless I'm willing to figure out what you're interested in. So if I know you're looking in the market for a car, I can serve you that same ad for literally 50 to 100 times the price than if I didn't know that you're looking for a car, right? And that's how we sort of generated a lot of value purely on data, right, by gathering this data. So how did it work? Well, you get this data. You target the ads based on it, the data we showed you before. You analyze the patterns. You build models for each one of these categories, hundreds or thousands of these categories, predictive models. And then you score the whole population. You go over the 600 million users in my time, and you sort of predict for each category what's the likelihood that they're going to be interested. By the way, because you cannot do this in real time, so you have to pre-compute everything, right? Because you only have milliseconds to serve up these ads. And then you target the ads and sort of refine the system. So what kind of results do you get? Well, you get results that are very interesting. I'll show you a couple. But here's where it's going to get very interesting. Let's say I'm watching you, and you're like searching on a car, right? So what the statistics tell me, the more you search on a car, the more you're a car guy, right? But then what happens to you? You buy the car, and what happens? Your interest, if I'm modeling your interest, should really drop, right? You're no longer, it's going to be useless to show you car ads, right, once you bought it. Or it could be a digital camera, it could be whatever. But the point I'm trying to make is these have different aging models. So for a car, it's a 3-month cycle. For a digital camera, it might be 2 days, right, and so forth. For a mortgage, it's a few weeks, what have you. So when you build models, you cannot do it purely on statistics. Well, technically, it's all purely statistics, but you cannot do it just by watching numbers. You have to understand the context, and you have to understand the business process or what the human being is going through. And then you have to model it and do this kind of aging. And then you have to go through, and for all these predictive models you generated, you have to maintain them. Sounds very boring. Sounds like garbage work. Probably not what you'd like to do for your PhD thesis. But it's absolutely necessary, because if you don't do it, you're predicting junk, right? Because you didn't update the models correctly. You didn't refresh them. They're probably reading inputs that are no longer valid, what have you, when you do this at scale. This stuff I just talked about, the stuff that actually makes it a business, is not covered in any of the books. Very few places do you find how do you manage models over time, how do you age them, and all that kind of stuff. But it's really, really important stuff. That's a big deal, and actually I think contains very interesting academic problems. Here's an example answer, for example, where we were trying to predict interest in a car. In this case, they didn't want to share publicly the data around buying cars, but they were comfortable saying, OK, this gives us 900% conversion lift on doing certain actions we care about, like you downloaded a brochure or you requested a quote or something. 900%. This is just by watching behavior. I can actually predict 9 times over random, much better than random, by watching that behavior. Or not random, 900 over the traditional ways of doing it. This is data on mortgages back when in the US when people still took out mortgages. So conversion lift, CTR lift is 122% click-through rate. So if you show these ads to these targeted people, you can actually get 122 times increase in CTR. But what's more important, what's more interesting is the statistics underneath it is even better. The conversion is 600% lift, meaning this is a person who actually applied and took out a new mortgage, right? So these algorithms are actually finding the right population, as an example. So that I wanted to give you a taste for a couple of these samples. And this business, this behavioral targeting, by the time, 3 years after my joining, was generating an incremental 400 million a year, right? By being able to sell ads. And by the way, this was one of these things I consider win-win-win, right? Because for the consumer, we're showing them the ads they're interested in. For the advertiser, they're getting exactly the audiences they want. And for the company, we're making a hell of a lot more money, right? So those are the kinds of things that are good. Lessons learned, though, is there's a lot more data than qualified talent. So finding the right talent and retaining it. By the way, I mean, it's a statistic I'm proud of. A lot of the folks, the managers in that data team that I built at Yahoo, today are actually CEOs of companies just went public, right? In the advertising business and in related big data spaces. Data people like to have critical mass. They need to be around other data people. And driving efforts by business needs, not by technology priorities. You get amazing technology priorities, but if you couple it to the business needs, you're following the right ones. And that's key to making it work. I wanted to give you a quick case study on a company called RapidMiner. Disclaimer, I'm on their board, but here's why I wanted to share the information with you. It's an open source software. It's a bunch of data mining algorithms and statistical, predictive analytics algorithms, right? Lots of amazing names of companies use it. This is a company that came out of a university in Germany, in Dortmund, right? But here is the amazing thing. 30,000 downloads a month. Actually, the number now is up to 40,000. This is not Candy Crusher, right? This is not a game. To download this damn thing, you actually must have a problem. You have to have data, and you have a prediction problem on your hand, and you need to analyze it. Now, half of them are actually academic, which is a good thing. So this is people in academia using the tool to do probably their class assignments and so forth. But the other half is actually companies. So to me, this is one of the big amazing things to me, that there's a lot of demand out there. And I think one of the biggest things about this tool is it's easy to use, right? And they've done, some of the companies agree to share sort of the public story. So PayPal uses it, who is now a separate company out of eBay, to basically figure out customer feedback and what it means. SmartSoft uses it for fraud detection applications. These algorithms, by the way, they are the same fundamental algorithms, but you can use them for a variety of these techniques, right? The problems can vary. The algorithms are roughly the same, right? Which is pretty handy. And all they do is they say, I have training data, right? Which is all the historical data that says when did an event happen, when didn't it happen, when something desirable came out in outcome. And actually, Professor Hand is one of the world's experts on classification and a lot of these techniques. The reason I'm excited about them is this Hadoop thing. So these guys have all these downloads when the data was in regular databases. So what happened is we're seeing a lot of data move into Hadoop because of the forces I just mentioned, storage and ETL and all that kind of stuff. And what these guys have done recently is they've gone out and bought a company called Radoop out of out of Budapest that basically does RapidMiner on Hadoop. But to me, this is very big news, right? Because suddenly you can actually drag and drop. It's got this nice graphical interface in RapidMiner where you say, okay, I want to analyze data. I want to bring it from here, here, here. Hit a button. It compiles it out and runs it on this Hadoop and new now Hadoop Cloud. So that's very powerful stuff. It's exciting to me because it brings analytics and all this powerful hardware to the hands of the analysts and a lot more people that would use it that normally wouldn't use it. One theme I want to leave you with, and I need to finish so we can do questions, is all data analysis regimes are breaking down. These data sets, the introduction of unstructured and semi-structured is really breaking down a lot of the old world. The world of data warehousing and enterprise is completely changing because of the move to things like Hadoop and new ways of storing data. So there's huge opportunities there for you who are working on your next career, or you're working on your research problem for your PhD thesis or what have you. And we still have big unsolved problems like semantics of content, semantics of location, how do you act on that data, all that good stuff. I wanted to end on a couple of reminders that it doesn't have to be always fancy. So I like to end on the simple examples. I'm going to share with you something I call a stupid data trick. Mail and news. This is at Yahoo. At Yahoo, the mail business unit, right? And Yahoo had 120 business units, right? Mail, finance, news, personals. I forget all the. Mail had a problem. If you open a mail account, in the first few weeks of your opening a mail account, you're very likely to churn, meaning you'll disappear and we'll never see you again. Why? Well, for some part of the population, because you probably opened it just as a spam thing, right? You're trying to sell a car and you open a temporary account. But for another part is you haven't connected to your friends, people don't know the address, you haven't given it out, so it's not sticky. And they had this problem. They were saying, we need to try to keep these users, right? So here's a stupid data trick. The team goes and looks at the data, and he says, to this day, I still don't understand this phenomenon. When you read email, you read news. Don't ask me why. I have no idea what this says about the human condition. But it's a fact. Now, here's what's scary. So, of course, the mail unit said, oh, whenever you log into your email, we'll show you this news preview module, right? It sounds crazy, right? Why? I'm logging into email, and they're showing me news stories, right? That act alone reduces churn by 40%. I cannot explain it, guys, but it's facts. Right? And it's simple stuff. They looked for simple correlations, and they acted on them. Another one that I'd like to share and wrap up is a company called Nordstrom. It's a department store, sort of like, what would be the equivalent here? No, it's higher end than M&S, slightly higher end. Maybe Selfridges, maybe, right? So, and Nordstrom, they pride themselves on knowing the customer, and actually, if you ask me questions about data privacy, I have a nice story about Nordstrom. But the marketing manager who was working with us, a woman named Julie Bornstein, really smart lady, she was looking at a lot of the analytics we were giving her, and then she asked me a question I never thought about. What are people searching for and not finding on my site? Like, you never think about this because you're reporting, common searches, all this stuff. She's saying, give me searches that return no results, right? One of them was belly button rings. Nordstrom doesn't sell belly button rings. But she saw a lot of traffic demand on belly button rings. So she actually decides, OK, I'm going to start stocking and selling belly button rings, right? But she also does a little bit more research. And by the way, she starts selling $400 belly button rings. I never knew they were that expensive. But she does some research. Why the sudden demand? And it turns out that in Nordstrom, another part, the offline store, they had a huge marketing campaign in newspapers. They were trying to sell underwear, right, some fancy underwear. But the models they were using were sporting belly button rings. So consumers would see the images, and they actually search on the belly button rings on Nordstrom, right? So that pattern was so strong that the offline stores, which is a huge network, public company, started selling belly button rings, right? Again, I call it stupid data trick, right? Because you make a simple observation that actually changes the business completely. Now imagine what you can do with the deeper observations where you really know what you want to do with the business, right? So with that story, I'll end with this. Analytics, to me, the next frontier, the big challenge for you. Probably the most complicated device that you use in your daily life, maybe not in London, but in the US definitely, is the automobile, right? And if you go back to the beginning of automobiles, you had to have a specialized garage, sometimes a driver, a lot of tools, certainly. And if the damn thing turned off, good luck, right? All that stuff. Today, you just get in the car, you push a button, and somehow you have some of the most powerful technology in the world working for you. Most of you don't even understand what's happening, the intricacies of the internal combustion engine, and why is it doing injection and not, spraying the fuel and all that kind of stuff. Really, really advanced science, all sorts of analysis that goes into what is the shape of that injector and how do you actually spit the mixture into the cylinder, all that stuff. Completely invisible to you. It just works. Boom, right? And now it's no longer a key, right? It's a button. And soon it's just voice. And it's all electric, no more injection. So that's, I think, where we need to be heading. That's the real true test of making a technology useful in daily life. That very, very high complication under the hood, but it just works. And with that, I want to end with an advertisement. I am at Barclays. We are hiring really good data people. I actually asked my colleagues before coming here, and by the way, we have really cool programs for students. If you want to spend the summer, or actually what we call off-cycle, like not even the summer, we have programs for you, and we'd love to have you. Actually, we have 2 of our future leaders, graduates here. I asked my colleagues, what would you like to say to an audience at Imperial College? And I actually give you quotations here. But look at where they came from. This is how much excitement is in the company. The head of Barclaycard US, right, in the US, and he hears about Imperial College. He says, we have a challenge to quadruple our business here in the US, and that can only be delivered through analytics, marketing, risk, fraud, operations. And Wilmington, Delaware is the undisputed center. And I told him, Amir, do you really want me to use your name with this quote? He said, absolutely. But also the CIO of our investment bank lists a whole bunch of very, very exciting areas. If you're interested, they're amazing. They do amazing stuff in the investment bank on the quant and so forth. And of course, the top 2 are from DSI, which happens to be Data Systems and Insights, not the Data Science Institute, but good to be here. And we have these little cards on the tables, and if you need more, I have some. So if you're interested, please contact me. And I give my contacts here. I give my assistant's address because I don't read email. I can't keep up. But if you send her, I will respond. And with that, we definitely have time for questions. So I would love to hear questions from you. Thank you.